Let's say we have to find the square root of 2. Start with a number, it can be any number, and multiply that number with such a quantity such that their product equals 2. Or to say that their product equals the number whose square root has to be found. Then pick the average of these two numbers and multiply it with such a number to again get 2. And average these two new numbers and continue this process on, and what this average will be approaching is a rational approximation to square root 2. But why does this method works? Just to say, why does the limit of averages of two numbers whose product is the number whose square root has to be found is approaching the square root itself? Go with it for a second and I promise we will go deep into the essence of his method. To answer, let us consider a rectangle with an area equal to 2. If we let one side to be a rational number g, then the other side becomes 2 by g as their product equals 2. Now the first key point is that g can never be equal to the other side 2 by g, because in that case the rectangle will form a square with equal lengths, or to say g will equal 2 by g or g squared will equal 2, which is impossible as we know the square root of 2 is irrational. But we have defined the g to be a rational number, and the square with area 2 has side length equal to the square root 2. So by that argument, g is always greater than square root 2, and 2 by g is always smaller than square root 2. And we will use this point later in the video. So now we just need a method to decrease the side g of the rectangle such that the rectangle will approach a square of side length square root 2. I will emphasize that I am using the word rectangle will approach the square because it can never be equal to it. To recap what I have said up to now, that we have to come up with a mechanism to decrease the side length g of the rectangle with area 2 in such a way the rectangle will approach the square of area 2, and the value of g will getting closer and closer to 2 by g, and both will be approaching the square root 2 but never be equal to it. And what turns out to be is that there is a neat way to do such an approximation, which is called as divide and average method. That is, if we take the original side lengths and average them, the average will always be a better guess to the square root 2. And then we make this average our new guess that will be closer to the square root 2. And if we continue this process up to theoretically infinity, we will get a better and better approximation to square root 2. And why the average of g and 2 by g is a better guess to square root 2, and why it always keeps on become more closer to it can be easily seen by arithmetic reasoning. One thing we already have proved is that g is always greater than square root 2 and g by 2 is always smaller than square root 2. So we just have to prove that average of g and 2 by g always lies between g and square root 2. Because if we prove it, we will make this average our new guess, and we will be sure that the new guess is closer to square root 2, as the new guess for sure lies between the previous guess and the square root 2. So to say, we have to prove that average of two numbers is always greater than the square root of their product, which you may have already learned in the arithmetic and geometric series, and here I also have given a simple proof. In a more geometric version, what it all means is that as the square with side length g is getting closer and closer to that of a square with side length 2 by g, we are approaching a square with a side length square root 2, which is always between the other two squares, and g will never be equal to 2 by g, but both will be approaching the square root 2. And this method can be used to estimate the square root of any number in rational fractions. But let us restrain ourselves to this point, and if you like the video and its content, subscribe.